take a look at factorial. So definition of a factorial. If n is a positive integer, then n factorial is defined as n factorial equals 1 times 2 times 3 times 4 all the way to n minus 1 times n. Okay, so that's the definition of it. And then as a special case, 0 factorial is defined as 0 factorial is 1. What I want you to notice is that 1 factorial is 1, 2 factorial is 1 times 2, which equals 2. 3 factorial is 1 times 2 times 3, which is 6. And 4 factorial is 1 times 2 times 3 times 4, which is 24. Factorials follow the same conventions for order of operations as exponents. So, for example, you have 2 times n factorial, so you do the n factorial first, and then you multiply 2 at the end. If it's parentheses 2 times n factorial, then this is how you would write it out. So we're going to write the terms of a sequence involving factorials. So write the first 5 terms of the sequence given by a sub n equals 2 to the n over n factorial. And then it tells us to begin with n equals 0. So let's start with that. So a sub 0 equals 2 to the 0 over 0 factorial. So 2 to the 0 is 1. 0 factorial, remember, is 1, so it's 1. So a sub 1, 2 to the first over 1 factorial. That's going to be 2 over 1, which is 2. A sub 2 is 2 squared over 2 factorial. And so that's 4 over 1 times 2, which is 2. And then the fourth term actually, 2 to the third power over 3 factorial, is 8 over 1 times 2 times 3. So that's 8 over 6, or that reduces to 4 over 3. Then we look at the a sub 4, which is our fifth term. So 2 to the fourth power over 4 factorial. So 2 to the fourth power is 16. Now another way to look at this is that you know that 3 factorial is 6. So then we just multiply one more number, the 4. So 6 times 4, that gives us 24. So just kind of a quick way to figure out the next number. And then this reduces to 8 goes into both of them. So it's 2 over 3. So the first 5 terms are 1, 2, 2, 4 over 3, and 2 over 3. So try this example here. Find the first 5 terms of the sequence given by this. Okay, so if you tried it out, you should have gotten 2, 4, 5, 14 over 3, and 41 over 12. Now let's look at simplifying factorial expressions. When fractions involve factorials, you can often divide out common factors. So for letter A, for example, we have 8 factorial over 2 factorial times 6 factorial. So one way to do this, now the long way to do this, is to say it's 1 times 2, and you list it all the way to 8, 5, 6, 7, 8, and then this is 1 times 2 times 1 times 2 times 3 times 4 times 5 times 6. Okay, so that's one way to do it, which is long. I'm hoping that you can see there's a shorter way to do this. So if I have 8 factorial here and I have 6 factorial here, what I'm going to do is do this backwards. I can do 8 times 7 times 6 factorial over, I'm going to go ahead and expand 1 times 2, so 2 times 1. And then 6 factorial, I can just leave it as 6 factorial. Now, because I have that, I can just cancel out the 6 factorial, and that part is done. I don't have to list this. And I hope you see that this is the same, right? I would just cancel out all of that. And then we can reduce this. So 2 goes into 8 4 times. So now this is just 1 in the denominator. So 4 times 7 is 28. Now let's look at B. We're looking at a factorial expression. And so I want to bring us back to the definition of a factorial. So we have n factorial is 1 times 2 times 3 times 4, and then n minus 1 times n. Now if we kept on going, just as an FYI, we would do n plus 1 times n plus 2, and so forth. We could even go backwards here. So if we have n minus 1, what's before n minus 1? Before n minus 1 is n minus 2. So I bring that up because when you see these later on in other problems, this is how the sequence goes to kind of help you out in simplifying. So B, we have n factorial over n minus 1 factorial. So let's kind of start to expand this first of all. And so we have n factorial, that is 1 times 2 times 3 and then it continues times n minus 1 times n, right? That's what the n factorial means. Then for the denominator, that's 1 times 2 times 3 times dot, 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 because it continues on to n minus 1, but there is no n, right? It stops at n minus 1, which is right before it. So therefore, when you simplify this, all of it cancels except for the n. So this is simplified as just n. I'm going to do one more. So in that case, we have n plus 2 over n minus 1 factorial. So let's write this out. So again, it's 1 times 2 times 3 times dot, dot, dot times n minus 1. And then n is next. Then n plus 1 times n plus 2. The denominator, it's 1 times 2 times 3 times dot, dot, dot times n minus 1, and it doesn't include the n, right? It stops it right before the n. So now when we cancel this out, we cancel up to that point here, and now we're left with n times n plus 1 times n plus 2, and then you can multiply that all the way through. I'm sure you could do that, but I just wanted you to see how you would do that type of a problem. So try this example here. Simplify the factorial expression, 4 factorial over n plus 1 factorial over 3 factorial n factorial. So trying this out, this is what you could have written. You have 4 times 3 factorial, and then 3 factorials on the bottom, so that makes it a lot faster. And then dealing with the n plus 1 factorial, so 1 times 2 times 3, all the way to n plus 1. And then in the denominator, you go up to the n, and notice 3 factorial cancels, these cancel, and so you're left with 4 times n plus 1.